Okay, so let's implement the firearm weapon logic. So in the previous tutorial, we have covered like how we can implement these BPI fire events and other stuffs. Yeah, so let's continue from this position on. Okay, so there are certain stuffs that I need to cover. Right. So since I'm going to have multiple different configurations, I think better to implement a specific data structure for that. Right? Because here you can see at the parent weapon base class, we have this weapon config data structure that generalize like all the common weapon configurations that we have for each of our child instances and all. So similarly, like since this is a base class for any sort of a firearm weapon, let's create a new data structure that's handle all of those configurations. Right, I'll go to the data folder, structs, weapon. I'll create a new blueprint structure called S firearm weapon config. Right, so there are certain configurations that we require. So since this is a firearm weapon, like it has sort of like an ammo count, right? So let's add a variables called magazine ammo, which is an integer, right? And what else we can add? Then we can add maybe magazine size, which is how many magazines that we have. And what else? Be like spare ammo, like how many amounts that we have in our equipped weapon, something like that, right? So as the default values, I'll give magazine ammo as 10, magazine size as 1, spare ammo as maybe, I don't know, maybe let's say 100. This is just a value, like you can give whatever the value that you need. Right, so then let's go to the firearm weapon and I'll sort of close rest of these stuff. Right, and here I'll add that specific not a function, specific variable, which is firearm weapon config as the type of S firearm weapon config, and make sure to mark it as instant readable, plus as the category let's move it to setup firearm. Right, so we have a better modularity. For example, like if you click on the firearm weapon, now at the setup category we have weapon config at the topmost, and we have the firearm category, and we have the firearm weapon configurations over there. Right, then what we can do, then first let's the variable called is firing. So if this one is true, which means we are currently firing, right? So we have that context here, and if we are firing, then we can do certain stuff. Yeah, for example, if you're firing, the character should strafe, or the character should actually um, look into that specific direction, right? For example, like currently the actor or character, whenever it's equip the weapon and start firing, is looking at this direction. But instead, I just need to make the character look in this direction where the camera is being targeted to. So in order to do that, we should get the locomotion system of the owner. So at the weapon base, do we have the reference for the owner? Yeah, we have the reference called owner ref, and here at the weapon base begin play, I'll get the owner ref and get the locomotion system and promote it to a variable called locomotion system, right? So we have a reference for the parent actor's locomotion system, and I'll go back to the firearm weapon base, and there we now can get the locomotion system because this one is initialized at the parent class. And let's get the rotation mode, right? And I can simply catch whatever the rotation mode that we had previously, right, before the firing. So I'll mark it as, rename it as cached rotation mode, and then I can set the rotation mode, whatever the rotation mode that I require. So here I think we need to strafe instead of forward facing, right? And let's say if I'm not firing, or if I stop the firing, then it should go back to whatever the previous rotation mode that we had, right? So I'll plug the cache rotation mode here. Okay, we can test that thing. Let's equip a weapon and fire. You can see actually the character is rotating in that specific direction, just exactly what we needed, right? Okay, and then we should be able to fire a weapon continuously, right? So how we can do that? Maybe like fire the weapon in like the finite interval, right? So we can add sort of like a shoot delay, but yeah, I'll add that maybe later. For now, let's add a reroute node by connecting these two stuffs, and maybe we don't need a reroute node to here, only this one would be fine. And let's add like a weapon firing trace logic, right? Because we need to actually detect where we fired. So here actually we can use sort of like a line tracing, but I'll add a dedicated function for that called get hit results, right? And this function should be a pure function. I just need to return a certain level of hit locations, right? And also this weapon can have a single petal or like multiple petals. For example, let's say if I am firing a pistol, then it should petal the bullet only once at the specific scattered location. But for example, let's say if I shoot a shotgun, then it has multiple petals within a single firing call. So in order to determine how many petals that we have, I think we can add another variable to our firearm weapons config data structure called pellets. And by default, I'll add a 1 pellet. And later on, we can override these values, whatever the way we want. Right. And then I'll go back to the firearm weapon base, get hit results function. So let's get the firearm config and let's break it. And I just need to see how many petals that we have. So I'll make a hit trace or line trace for each pellet by using a for loop actually. Starting from 0 to whatever the petal amount that we have. So -1. And then let's get the owner reference. No, not the owner. Let's directly make a line trace by channel, I would say. And the trace channel, for now I think we can accept the visibility. And we need to determine what's the start location, what's the end location. So in order to detect that, maybe we can add another function called get trace location, because if I add one location here like this, one start location and one end location by directly, what happen is like whenever we have the multiple pellets, it hits to the same location, right? But I don't want to do that. Maybe like, let's say if we have multiple pellets, then we should be have sort of like a deviation in between the start and end location, and not the start location explicitly, maybe at least the end location, right? So to make those variations, I think it would be nice to have a dedicated functions to get the trace location. Right. So this one basically return two locations, namely start location, which is a vector, and the end location. And as the start location, I can directly get the camera transform location. To that, I will add a dedicated function first. So I'll make a function called get camera transform, right? This should be the pure function also, and it should return the return value, which is the type of transform, right? Right, then let's get the owner and let's check whether this one is player controlled or not. So we can determine whether this one is player controlled. So actually we have to cast to character, but I think since we are going to need some castings for character later on, maybe we can add those and stuff to one of our blueprint function libraries, maybe at the utilities. So a new function called get character, which is a pure function as the type of output, which is a character return. Well, and as the input, it should consume any sort of an actor. So I'll give it like owner, type of actor, and let's cast to character and if this is a successful cast, we can return the character, else we can return the null reference. Right, now let's go back to the firearm weapon base, and there I can get the character by using this BFL utility. And now I can check whether this one is player controlled or not. So if this one is player controlled, then we can initiate the fire. We can actually get the actual character transform because it has the player controller. Otherwise, we don't have the character camera, which means like NPC character or whatever. Then it should return the actor transform instead. Right? Hope you get the idea. So this function is basically checking whether we are the character or not. Because if we are the character, actually in our player base, we have a camera. Right? If you remember at the player base, we have this camera. Right? So we can get the camera transform directly. But at the NPC level, for the NPC base, we don't have a camera, right? So we can't actually take the camera transform directly. Instead, we have to like sort of mask camera location or the camera transform by using this actors transform, right? That's the idea. Okay, so if this one is player control, then we have to explicitly consider the camera transforms. Else, we can simply return whatever this actors transform. So get actor transform, right? Okay, and then we should be able to get our player's camera. So I'll maybe we have the get owner here. So I'll use it again. Maybe instead of the get owner, we can use the owner ref. Right, and let's get the owner ref, and here let's cast to player base. Player base, and in our player base, we have the camera. So let's get the camera, and there we can get the transform. Get yeah, maybe get world transform, right? And then let's return it. But I don't think like this would be the good practice, like explicitly casting the player base. Instead, actually we should have sort of a way to get the camera location using the play camera manager. But yeah, for now this would be fine. Later on I will add this dedicated camera manager for our player base so that we have a better control with it, right? For now, just for testing, let's edit like this and you'll see how it works. Okay, so I'm getting the camera transform if it is the actual player character, else I'm just getting the actor transform as the camera transform if the character doesn't inherit the camera within it, right? Then let's go to the trace location again, and I'll get the transform, split it, and as the start location I can get whatever the start location I have. But for the end, actually we should have some sort of a randomization, right? Because as I told you before, if you have multiple pellets, it shouldn't hit for the same location. Plus later on actually I'm going to sort of like implementing the weapon accuracy loss. So in such scenarios actually, based on the accuracy, we should randomize the target hit location as well. So anyway, to address all of those stuff, I will sort of use the random point in bounding box functionality. And for now, as the half size, I will use a 1 by 1 by 1 bounding box, right? And return as the end result. Right. Again, this one is just a naive way of getting the trace location. We can further improve this one, right? Just for now, for the basic testings, let's add in this way, and later on we can improve this further. Right, then I'll go back to the get hit results function, and I can use that get trace location functionality. One other thing, like make sure to make this as a pure function, right? Because we are simply returning a value, we are not manipulating or modifying any sort of existing variables. Right, so as the start location I can get this one, as the end location I can get this one, and as the actors to ignore, maybe we can make an array, and we can ignore the owner reference, right? Because if this trace is sort of like intercepting or sort of like overlapping with the owner's skeleton meshes or whatever the capsule component that it has, it shouldn't take it as a hit, right? So it should ignore it. That's why actually I made this one as actor to ignore. And just for testing, I just need to see how the line trace works. So I will add this for duration, right? And then we can actually check whether this one is a valid hit or not by using this return value. So if it is a valid hit, then it return a true, else it false. Right, so if this one is a valid hit, then it should return a valid hit, but since we have multiple petals, actually it's going to return multiple different hit results. Therefore I will create a new local variable called l underscore hit results, and this should be the type of hit result, and it should be an array. And this one is a successful call. I'll add this to this hit result. Right, and let's say in case if this is not a valid hit result, then I should mask whatever the hit result by like sort of determining the returned end value. Therefore I will add it like this, but I will make a hit result, right? So as the makings, I am sort of interested of making the impact point and the impact normal. So we can directly get this end and attach it to here and to here. Right, like so. This is sort of like a predicting whatever the end result, if this is not a valid hit, right? And then after all, we can return it, which is this hit results, right? So I'll call this as return values. Right, finally we can go to our maybe like PPI file, and there we can implement our function, which is this one, get hit results. So this should actually call a specific event which is actual file, right? So this is implemented event, but I'll implement the internal event called fire to handle those hit results. So simply call it as fire, and as the input it should consume hit results, and the type of hit result which is an error. Right, now I can call that event here, and for now I will simply add a print statement, right? Call fire. Right, now I think finally we can play test. So I'll pick a weapon and fire. Oh, let's look at the output log. Yeah, it's been fired, but why it doesn't print it? We have one pellet, and does this one at least called once? Let's check that one. It's been called. Then I think the issue is at here. Get the trace location, get camera transform, because I'm getting the world transform, right? Right. So maybe at here, let's try to draw debug sphere. I'll take the duration as 10, thickness as 10, and let's break it, and I just need its location. Right, now let's play test it again. Okay, here you can see actually the trace is working properly, but the end is, I don't think, quite accurate, because it's detecting the location properly. So you can see, like, if I press it again, it draws a spear here, which is actually, that's the position where our camera has, right? So the location is okay. Okay, I think the start and the end is almost close. That's why it has that sort of a issue. So what I can do is I can add sort of a forward vector adjustment, right? But I think it will take some time because we need to configure multiple different stuff to implement that feature. So I think since this video is getting longer than 30 minutes, I will stop it from here, and I will continue it from the part 2. Okay, I'll see you guys. Thank you.